In this video, we will see an example on phasors. Question: find the sinusoids corresponding to these phasors. So here the voltage phasor is given, also the current phasor is given. It is in this voltage phasor is in polar form, and here this current phasor is in rectangular form. So first of all, let's solve this first question or first phasor. So let's write it here. Now solution for this will be, here it is in polar form, it is the polar form. So what we will do, we have to find sinusoids corresponding to these phasors. So we have to find v of t, and this will be, here the value of amplitude is minus 10. So this will be minus 10 as it is, then cos omega t plus 30 degree. Now here we can see it is in minus, so we need to convert this minus to plus. Let's go to the basics. So here this is plus cos omega t on this horizontal axis, and here this is minus cos omega t. This is plus sin omega t, and this is minus sin omega t. The phasor rotate in this direction. So we want to convert this minus cos into plus cos. So here is the minus cos omega t, we have to change it into plus cos omega t. So we can move in this direction like this. So the difference is 180 degree. So it is plus 180 degree, because if we move from here to here in this direction, so we have to add 180 degree. And if we move in opposite direction, this is also correct, but this direction is opposite, so we have to subtract 180 degree. So both are correct. So here we can write cos omega t plus 180 degree is equal to minus cos omega t, and also cos omega t minus 180 degree is equal to minus cos omega t. So minus 180 degree is equal to minus cos omega t, both are correct. Now we have to change this minus sign. So what we will do, this will be v of t is equal to 10 cos omega t plus 30 degree. So it is as it is. Then we have to add 180 degree. So this will be plus 180 degree. So this will be v of t is equal to 10 cos omega t plus this will be 210 degree. So this is the answer in time domain format, or it is in sinusoids form. Now second question, we have to convert this phasor into its equivalent sinusoids. So let's paste the question. Now here it is given in rectangular form, and we know that j is equal to, this is the solution, so j is equal to 1 at an angle 90 degree, and here this is 5 minus j12. So 5 minus j12 is equal to, this is in rectangular form. In polar form, this will be under root of 5 square plus minus 12 square at an angle tan inverse of y by x. The value of y is minus 12 divided by 5. So this will be under root of 5 square plus in bracket minus 12 square. So it is 13 at an angle tan inverse of minus 12 by 5. So minus 12 divided by 5, that is minus 67.38. Minus 67.38 degree. Minus 67.38 degree. Now let's multiply it. So here first we will write this 5 minus j12. Now in place of this j we can substitute 1 at an angle 90 degree. So let's substitute it. I is equal to in bracket 1 at an angle 90 degree, and in place of this 5 minus j12 we can substitute this value 13 at an angle minus 67.38 degree. Now why we change from this rectangular form to this polar form? Because multiplication and division are better performed in polar form, and this is the polar form of this both. Now we can easily multiply it. So this will be I is equal to 1 into 13 at an angle. Now this will be added. So 19 degree plus minus 67.38. Minus 67.38. So this will be I is equal to 13 at an angle 90 plus in bracket minus 67.38. So this will be 22.62. 22.62 degree. Since it is current, so its unit will be ampere. Now its time domain format will be I of t is equal to 13 cos omega t plus 22.62 degree ampere. So this is the I of t in time domain format. So this is how we can solve sinusoids corresponding to these phasors. That means this is how we can convert phasors into its equivalent sinusoids. Don't forget to share to this video, and thanks for watching. If you want more videos like this, then subscribe to this channel.